It's 1978, and Cold War tensions are at an all-time high. During routine security checks at the US Embassy in Moscow, inspectors uncover a mysterious antenna hidden in a chimney. Attached to a cable running to nearby Soviet property, the device isn't a typical microphone, and its purpose is unclear. This discovery follows years of suspicion about microwave emissions near the embassy, leaving US officials scrambling for answers. The IBM Selectric typewriter is introduced in 1961, at a time when traditional typewriters were mechanical devices that rely on individual type bars. These type bars often jam and produce inconsistent results. IBM seeks to change that with a groundbreaking design. The Selectric introduces the golf ball typing element, a spherical mechanism that contains all the letters, numbers, and symbols needed for typing. This allows users to easily switch between different fonts, providing unprecedented flexibility in document creation. But the Selectric isn't just about functionality, it is also about aesthetics. With its sleek modern design and a variety of color options, it quickly becomes a staple in offices around the world. As the Selectric gains popularity, it finds its way into government offices and diplomatic missions. Its ability to produce high-quality documents quickly makes it essential for officials who need to communicate effectively. But it isn't just businesses that take notice. Intelligence agencies around the world see the Selectric's unique design as an opportunity for something far more sinister. The Cold War era is a time of heightened tension between the United States and the Soviet Union. Both superpowers are locked in a technological and ideological race, where information is the most valuable commodity. Espionage is rampant, and every device has the potential to become a spy tool. On 25 March 1985, CBS television nightly news breaks the following shocking story.
In another U.S.-Soviet development, Pentagon correspondent David Martin has been told how Soviet secret police in Moscow have been getting the latest word on sensitive U.S. embassy documents even before U.S. officials read them.
Informed sources tell CBS News that for at least 1 year and probably longer, the American embassy in Moscow was the victim of a sophisticated electronic spy operation.
This revelation comes to light in 1984 when the United States National Security Agency, NSA, launches a top-secret mission called Project Gunman. The story begins with President Ronald Reagan receiving a warning from intelligence sources that the Soviet KGB has successfully implanted bugs in equipment used by Western embassies. Alarmed by the implications, Reagan acts swiftly and appoints Walter Dealey, the Deputy Director for Communications Security, to lead the mission. Dealey, in turn, develops a plan to remove, replace, and examine telecommunications and information processing equipment to counter the threat. The NSA aims to bring the equipment back to the United States for a more thorough inspection that couldn't be conducted on embassy grounds. The equipment includes teletype machines, printers, computers, cryptographic devices, and copiers. Basically, anything that plugs into a wall socket. Workers take their jobs seriously. Officials live in apartments outside the US compound, always under the watchful eye of the Soviets. They often come home to find their freezers unplugged, shirts missing from their closets, or dirty glasses in the sink. The Soviets have undoubtedly bugged these apartments. As the equipment from the embassy returns to the NSA, it begins a lengthy inspection process for each item. The equipment undergoes methodical inspection to prevent the destruction of important evidence. Every item undergoes visual inspections followed by X-ray analysis, and the resulting images compare against known standards to detect anomalies. Walter Dealey, known for his strong will, abrasiveness, and unwavering commitment, plays a pivotal role in driving the project. He is determined to uncover whether the Soviets have infiltrated US equipment and pushes for rapid progress. Demonstrating his impatience, he replaces project managers midway through the operation and even offers a $5,000 bonus to the first person who discovers a bug. One physicist describes the tense and focused atmosphere during the search. "The adrenaline is really flowing," he says. "A About 25 of us are involved, and we all understand the stakes. NSA's reputation is on the line, and it is up to us to find evidence of Soviet tampering. We are certain the Soviets are exploiting us. The breakthrough comes on the evening of July 23, 1984. An engineering technician notices something unusual in the power switch of an IBM Selectric typewriter. Upon closer examination and an X-ray of the machine, the technician discovers a hidden implant. The implant is a marvel of Cold War espionage. It includes a magnetometer that converts the mechanical energy of keystrokes into magnetic signals. These signals are then transmitted via radio frequencies to a nearby Soviet listening post. The device can be controlled remotely and is activated only when needed to avoid being detected. What makes the implant so insidious is how advanced it is for its time, including 1-bit core memory and integrated circuits, an advancement that NSA engineers have never seen. The bugging devices are meticulously designed to evade detection. For instance, the implants use short, intermittent radio transmissions, often concealed within the noise of Soviet television signals. They also operate on low power, further complicating detection by the outdated equipment used by US technical security countermeasures teams. Although the implant was a highly sophisticated device, it had some limitations that affected how it recorded characters. It couldn't detect special keys like shift, space, backspace, tab, and carriage return. Since it can't tell when the shift key is pressed, it always records lowercase letters, even if the shift key is used to type uppercase letters. Additionally, the hyphen and underscore can't be recorded because they are in a default position. As a result, a sentence like "meeting with Jerry at Tulip Hotel" is recorded as below. Upon discovery, NSA engineers undertake a comprehensive reverse engineering process to study the implants. They compare bugged and unbugged Selectric typewriters side by side, documenting every modification with video and photography. Unique characteristics of the bugged typewriters include additional springs, modified switches, and altered components that control the movement of the Selectric's iconic golf ball typing mechanism. The implant's sophistication reveals a deep understanding of US inspection techniques by the Soviet engineers, who designed their devices to filter out frequency harmonics that nonlinear detectors typically search for. Out of the 11 tons of equipment returned from the embassy, 16 IBM Selectric typewriters are found to be bugged. It highlights vulnerabilities in the US government's technical security protocols and forces a re-evaluation of practices for inspecting and shipping sensitive equipment. The Department of State, in particular, implements stricter policies and procedures to safeguard against future espionage attempts, many of which remain in effect today.